Welcome back to Science with Sleepy, where curiosity drifts like starlight. And tonight's journey stretches across 2 full hours, because the question of first contact never runs out of wonders. Imagine the lights dimmed low, a gentle hum of ambient sound behind my voice, and your favorite blanket pulled close as we drift into one of humanity's greatest questions. Picture this. It's a quiet night at a radio telescope observatory. Scientists are listening to the stars, listening for something that might never come. The telescope points at a distant star system. It's been listening for hours, days, years, decades, listening for a signal, a message, a sign that we're not alone. And then, something happens. A signal arrives, not from Earth, not from a satellite, not from natural space phenomena. A signal that shouldn't be there. A signal that carries information, a pattern, a message, from another civilization, from another world, from beings we've never met, from intelligence we've never imagined. What happens next? How do we respond? What does this mean for humanity? How do we communicate across vast distances? What are they like? What do they want? How do we build a relationship that spans light years and centuries? Tonight, we're going to explore exactly that. We're going to wander slowly through what happens when humanity makes first contact with an alien civilization. We'll drift from the science of searching for signals, all the way to the long-term implications for humanity's future. We'll discover how SETI searches the stars. We'll learn about the Drake equation and the probability of alien life. We'll explore the challenges of interstellar communication. We'll imagine what alien civilizations might be like. And we'll consider how humanity might respond to the greatest discovery in history. The story begins with a gentle question. Are we alone? For thousands of years, humans have looked up at the stars and wondered, are there other worlds, other beings, other civilizations? In the last century, we've begun to search, to listen, to reach out, to try to answer this ancient question. The answer might come tomorrow. It might come in 1,000 years. It might never come. But the search itself is beautiful. The patience required is peaceful. The wonder of possibility is calming. And that's what we'll explore tonight. As we drift through this long, gentle exploration, we'll discover how radio telescopes work, how scientists search for signals, how we might decode messages from other worlds. We'll talk about the vast distances of space, the time delays of light speed, the patience required for cosmic conversations. We'll explore what alien life might be like, how civilizations might evolve, what technology advanced beings might have. And we'll consider how humanity might change when we discover we're not alone. We'll learn about the Drake equation, a way of thinking about how many civilizations might exist. We'll explore the Fermi paradox, the question of why we haven't found anyone yet. We'll discover current SETI projects. Breakthrough Listen, the Allen Telescope Array, China's FAST Telescope, the Galileo Project. All searching, all listening, all hoping. We'll imagine the moment a signal arrives, how scientists would verify it, how they would decode it, how the world would react. We'll explore the challenges of interstellar communication, the vast distances, the time delays, the patience required. We'll consider what alien civilizations might be like, based on science, based on what we know about life, about evolution, about intelligence. We'll explore the Kardashev scale, a way of classifying civilizations by their technology, their energy use, their capabilities. We'll imagine how humanity might respond, how the world might change, how we might adapt, how we might grow. We'll explore the long-term implications, how contact might shape humanity's future, how it might inspire us, how it might connect us to something larger. All of this we'll explore peacefully, gently, with wonder and curiosity, with patience and acceptance, with the calm understanding that we don't know, that we're searching, that the search itself is beautiful. The search for extraterrestrial intelligence is one of humanity's most patient endeavors. It requires listening for signals that might never come. It requires patience across decades. It requires hope that somewhere, in the vast cosmos, another civilization is also searching, also listening, also wondering if they're alone. This question touches on everything, on how we understand life, on how we understand intelligence, on how we understand our place in the universe. As we explore tonight, we're not just learning about aliens, we're learning about ourselves, about our curiosity, about our patience, about our hope. So settle in, let your breathing slow, and let your mind drift with me into the peaceful search for other civilizations. We're about to explore what happens when humanity makes first contact. The journey begins now, and it will take us from radio telescopes on Earth to the farthest reaches of the galaxy, all in calm language that is easy to follow. Chapter 1: The Search Begins. SETI and the Science of Discovery. To understand what happens when humanity makes first contact, we first need to understand how we search, how we listen, how we reach out into the cosmos, hoping for a response. This search has a name. SETI, the search for extraterrestrial intelligence. SETI is not about spaceships landing on Earth, it's not about little green men, it's about something much more peaceful, much more patient. It's about listening. Listening to the stars, listening for signals, listening for messages that might have been sent thousands of years ago, or might be sent thousands of years from now. The idea is simple. If there are other civilizations out there, they might be trying to communicate, they might be sending signals into space, radio signals, light signals, some form of communication we can detect, and if we listen carefully enough, for long enough, we might hear them. But how do we listen? How do we search through the vastness of space for a signal that might not exist? The answer lies in radio telescopes. These are enormous dishes that point at the sky. They collect radio waves from space. Radio waves are a form of light, just like visible light, but with longer wavelengths. Our eyes can't see radio waves, but telescopes can detect them. Radio telescopes work by collecting these waves. The dish focuses them, like a mirror focusing light. The waves are converted into electrical signals. These signals are analyzed by computers. Computers look for patterns, for signals that stand out from the natural background noise of space. The electromagnetic spectrum is vast. It includes radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, gamma rays. All of these are forms of light. They're all electromagnetic radiation. They all travel at the same speed, the speed of light. But they have different wavelengths, different frequencies, different energies. Radio waves have long wavelengths. They can travel through space easily. They can pass through dust clouds. They can travel vast distances without being absorbed. This makes them ideal for interstellar communication. If aliens are trying to communicate, they might use radio waves. Because radio waves can travel far, they can carry information, they can be detected, but they might also use other forms of light. Laser signals, brief flashes of light. These could carry more information, they could be more efficient. But they'd be harder to detect. We'd need to be looking in exactly the right direction, at exactly the right time. The chances of catching a laser signal are smaller. But we're searching for them anyway, because we don't know what aliens might use. Space is full of natural radio signals. Stars emit radio waves. Galaxies emit radio waves. Pulsars emit regular pulses of radio waves, like cosmic lighthouses, rotating neutron stars sending out beams of radiation. Quasars emit enormous amounts of radio energy. Black holes can emit radio waves as they consume matter. Even empty space has a faint radio hum. This is the cosmic microwave background, the leftover radiation from the Big Bang. It's everywhere. It's been traveling through space for almost 14 billion years. Among all this natural noise, scientists search for something artificial, something that stands out, a signal that's too regular, too patterned, too information-rich to be natural, a signal that says, "We are here, we exist, we are trying to communicate." But among all this natural noise, scientists search for something artificial, something that shouldn't be there, a signal with a pattern. A signal that carries information, a signal that says, "We are here, we exist, we are trying to communicate." The search began in earnest in 1960. That's when astronomer Frank Drake conducted the first modern SETI experiment. He called it Project Ozma, named after the princess in L. Frank Baum's Oz books. He used a radio telescope in West Virginia, the Green Bank Telescope. He pointed it at two nearby stars, Tau Ceti and Epsilon Eridani. Both are similar to our Sun. Both are relatively close, about 12 light-years away. He listened for signals. For about 2 months, he didn't find any. But he started something. He showed that the search was possible, that we could listen, that we could try. Since then, the search has grown. More telescopes, more stars, more frequencies, more patience. Today, SETI projects search thousands of stars. They listen across millions of frequencies. They use some of the most powerful telescopes on Earth. And they've been listening for over 60 years. The SETI Institute was founded in 1984. It's dedicated to the search for extraterrestrial intelligence. It conducts research. It develops technology. It searches the skies. It's been at the forefront of SETI for decades. It continues to search, to listen, to hope. NASA has been involved in SETI. In 1992, NASA began a SETI program, but it was cancelled after just 1 year, due to budget cuts. But the work continued. Through private funding, through universities, through dedicated scientists. The search never stopped. It just continued in different ways. Today, SETI is more active than ever. More telescopes, more computing power, more sophisticated methods, more patience. The search continues, peacefully, patiently, with wonder and hope. But here's something important to understand. We haven't found anything yet. Not a single confirmed signal from an alien civilization. This might seem disappointing, but it's actually quite peaceful. Because the search itself is beautiful, the patience required is calming. The wonder of possibility is enough. Why haven't we found anything? There are many possible reasons. Space is vast, incredibly vast. The nearest star to our Sun is Proxima Centauri. It's about 4.2 light-years away. That means light takes 4.2 years to travel from there to here. If there's a civilization there, and they send us a signal, it will take over 4 years to arrive. But most stars are much farther away. Hundreds of light-years. Thousands. Millions. If a civilization 1,000 light-years away sends us a signal, it will take 1,000 years to arrive. By the time we receive it, that civilization might be gone. Or they might have evolved beyond recognition. Or they might have moved on to other forms of communication we can't detect. Time is also vast. Civilizations might rise and fall. They might exist for thousands of years. Or millions. but the universe is billions of years old. The chances of two civilizations existing at the same time, in the same place, close enough to communicate, might be very small. This is part of what makes the search peaceful. It's not urgent, it's not rushed, it's patient, it's about listening, about being open to possibility, about the wonder of the search itself. In 1961, Frank Drake created something called the Drake equation. This isn't really an equation you solve. It's more like a way of thinking, a way of breaking down the question how many civilizations might be out there. The Drake equation has several factors. How many stars are there in our galaxy? How many of those stars have planets? How many of those planets could support life? How often does life actually arise? How often does life develop intelligence? How often do intelligent civilizations develop technology? How long do those civilizations last? We can estimate some of these factors. We know there are billions of stars in our galaxy. We know many stars have planets. We've discovered thousands of exoplanets. Planets orbiting other stars. Some of them might be in the habitable zone, the zone where liquid water could exist, where life as we know it might be possible. But we don't know the other factors. We don't know how often life arises. We don't know if intelligence is common or rare. We don't know how long civilizations last. So the Drake equation doesn't give us an answer. It gives us a way to think about the question. Some scientists estimate there might be millions of civilizations in our galaxy. Others estimate there might be just one, us. Recent research has tried to narrow this down. One study estimated that there might be at least 36 active communicating civilizations in our galaxy. 36. That's a specific number, but it comes with important caveats. These 36 civilizations, if they exist, would be very far away. The average distance would be about 17,000 light-years. 17,000 light-years. That's incredibly far. If a civilization that far away sends us a signal, it took 17,000 years to arrive. 17,000 years ago, humans were just beginning to develop agriculture. We were living in small groups. We hadn't invented writing yet. We were just starting to build civilizations. By the time we receive a signal from 17,000 light-years away, that civilization might be gone. They might have evolved beyond recognition. They might have moved on to forms of communication we can't detect. They might not exist anymore. But the estimate is interesting. It suggests that if intelligent civilizations exist, they might be rare. But not impossibly rare. They might be spread out, separated by vast distances. But they might exist. The truth is, we don't know. And that's okay. The not knowing is peaceful. The search is enough. There's another question that comes up. It's called the Fermi paradox. Named after physicist Enrico Fermi. He asked a simple question. If there are so many stars, so many planets, so many possibilities for life, where is everybody? Why haven't we seen any signs? Why is the universe so quiet? There are many possible answers. Maybe civilizations don't last long. Maybe they destroy themselves. Maybe they evolve beyond the need for technology. Maybe they're too far away. Maybe they're communicating in ways we can't detect. Maybe they're not interested in communicating. Maybe we're the first. Or maybe we're alone. We don't know. And again, that's okay. The question itself is beautiful. The search is peaceful. The wonder of possibility is calming. Current SETI projects continue the search. Breakthrough Listen is one of the largest. It's a 10-year project. It searches 1 million nearby stars. It listens across a wide range of frequencies. It uses some of the world's most powerful telescopes. It's been running since 2016. It hasn't found anything yet. But it's still listening. The Allen Telescope Array is another major SETI project. It's a collection of radio telescopes in California. It's designed specifically for SETI. It can observe multiple stars simultaneously. It can search across many frequencies at once. It's been listening since 2007. Still listening. Still searching. China's FAST telescope is one of the largest radio telescopes in the world. FAST stands for 500-meter aperture spherical radio telescope. It's 500 meters across. That's over 1,600 feet. It's the largest single-dish radio telescope on Earth. It began SETI observations in recent years. It's scanning the cosmos with incredible sensitivity, listening for signals that might have been missed by smaller telescopes. There are also optical SETI projects. These search for laser signals, brief flashes of light that might be messages. Laser communication could be more efficient than radio. It could carry more information. It could be harder to detect, but we're searching for it, looking for brief flashes, brief pulses of light that might be artificial. There are projects searching for techno-signatures, signs of advanced technology, like Dyson spheres. Hypothetical structures that advanced civilizations might build around stars to capture energy. These would be enormous. They would surround entire stars. They would capture most of the star's light. We could detect them by looking for stars that emit less visible light than they should. Stars that are dimmer than expected. Stars that might be surrounded by technology. Or we might look for signs of atmospheric pollution, chemicals that might indicate industrial activity. On Earth, we've changed our atmosphere. We've added carbon dioxide, we've added other chemicals. An advanced civilization might do the same. We could detect these chemicals in the atmospheres of exoplanets, using telescopes that analyze starlight passing through those atmospheres. The Galileo project is searching for something different. It's looking for artifacts, physical objects, probes, remnants of technology, things that might be in our solar system right now. The idea is called the Lurker hypothesis. It suggests that alien probes might already be here, monitoring Earth, waiting, observing, not making contact yet, but present. The Galileo project is systematically searching for such objects, using telescopes, using detection methods, looking for things that shouldn't be there. This is a peaceful search, a patient search, a search that acknowledges we might find nothing, but also acknowledges that the search itself has value, that listening has value, that being open to possibility has value. The search takes many forms, but they all share something: patience, wonder, the peaceful acceptance that we might never find anything, but the search itself is valuable, the listening is beautiful. The possibility is enough. In 1977, something interesting happened. A radio telescope in Ohio detected a signal. The Big Ear radio telescope at Ohio State University. It was strong. It lasted for 72 seconds. It had a pattern that suggested it might be artificial. The signal came from the direction of the constellation Sagittarius. It was at a frequency of 1420 MHz. This is significant. It's the frequency of hydrogen, the most common element in the universe. Scientists have suggested this might be a good frequency for interstellar communication, because it's universal, because any civilization studying astronomy would know about it. The astronomer who found it was Jerry Amon. He was reviewing data printouts. When he saw the signal, he wrote "wow" in the margin, so it became known as the wow signal. The signal was 30 times stronger than the background noise. It had the characteristics of a signal from space. Not from Earth, not from a satellite, but from deep space. Scientists tried to find it again. They listened to the same part of the sky. For years, they never detected it again. Was it a signal from an alien civilization? Probably not. It was more likely interference, or a natural phenomenon we don't fully understand. But it showed something. It showed that interesting signals can appear, that we need to keep listening, that the search continues. The wow signal remains a mystery. We'll probably never know what it was. But it's a reminder. A reminder that interesting things can happen, that we need to be ready, that we need to keep searching, that the universe is full of surprises. The search for extraterrestrial intelligence is one of humanity's most patient endeavors. It requires listening for signals that might never come. It requires patience across decades. It requires hope. But it's also peaceful. The vastness of space is calming. The patience required is meditative. The wonder of possibility is enough. Every night telescopes point at the stars. They listen, they search, they hope. This has been happening for over 60 years. And it will continue, for decades more, for centuries more, as long as humanity exists, as long as we're curious, as long as we wonder. The search connects us to something larger. It reminds us that we're part of a vast cosmos, that we're small, but also part of something beautiful, something vast, something full of possibility. The search is also collaborative. Scientists from around the world work together. They share data, they share methods, they share hope. This collaboration is beautiful. It shows humanity at its best, working together, searching together, hoping together. The search requires resources. Telescopes cost money. Computing power costs money. Research costs money. But people continue to fund it, because the search has value, because the possibility is worth it, because wonder is worth it. As we continue our journey, we'll explore what happens if a signal actually arrives, how we might detect it, how we might verify it, how we might decode it. But always remember, the search itself is beautiful, the listening is peaceful, the possibility is enough. The journey from searching to finding is a long one. It might never happen, but the search continues, patiently, peacefully, with wonder and hope. Every night, somewhere on Earth, a telescope is listening, pointing at the stars, searching, hoping. This has been happening for decades. It will continue. For as long as humanity exists, for as long as we're curious, for as long as we wonder. The search is funded by governments, by private donors, by universities, by people who believe, people who hope, people who wonder. They fund it not because they expect immediate results, but because the search has value, because wonder has value, because hope has value. The search also inspires. It inspires students, it inspires scientists, it inspires dreamers. It shows that we're looking outward, that we're reaching out, that we're open to possibility. This inspiration is valuable. It drives progress, it drives exploration, it drives wonder. The search connects us. It connects scientists around the world. It connects us to the cosmos. It connects us to possibility. It reminds us that we're part of something larger, that we're small, but also part of something vast, something beautiful, something full of wonder. The search also teaches us patience. It shows that some things take time, that some searches are long, that some hopes require waiting. This patience is valuable. It teaches us to appreciate the journey, not just the destination. It teaches us that the search itself has meaning, that wonder itself has value. The search also teaches us humility. It reminds us that we don't know everything, that we're still learning, that we're still exploring. This humility is peaceful, it's calming. It reminds us that not knowing is okay, that searching is enough, that wonder is enough. The search also gives us hope, hope that we're not alone, hope that connection is possible, hope that somewhere, civilizations are also searching, also listening, also wondering. This hope is beautiful, it's peaceful, it's calming. It gives meaning to the search, it gives purpose to the listening. This hope is not naive. It's not foolish, it's based on science, on probability, on the vastness of the universe, on the possibility that life exists elsewhere. This hope is grounded, it's realistic, but it's also beautiful, it's also peaceful. The hope also connects us, it connects us to other searchers, to other listeners, to other wanderers. It reminds us that we're not alone in our curiosity, that others share our wonder, that others share our hope. This connection is valuable, it's peaceful, it's calming. The hope also inspires action. It drives us to search, to listen, to wonder. It motivates us to build telescopes, to develop technology, to continue the search. This action is valuable, it's progress, it's growth, it's beautiful. So as we drift deeper into this exploration, keep in mind that SETI is fundamentally about listening, about being open, about the peaceful search for connection across the vastness of space. The methods are scientific, the tools are technological, but the heart of it is wonder, curiosity, the peaceful hope that we're not alone. To make this possible, we need to understand what we're listening for. And that brings us to the moment when a signal might actually arrive. Chapter 2: The signal arrives. Decoding the message. Imagine it's a quiet night at a radio telescope observatory. Scientists are going about their work, analyzing data, checking equipment, listening, as they have for years, decades. Then something appears on a computer screen. A signal, strong, clear, coming from a specific direction in space. A direction that doesn't correspond to any known source. Not a satellite, not interference, not a natural phenomenon. Something new. Something that shouldn't be there. What happens next? How do scientists verify this is real? How do they confirm it's actually from an alien civilization? How do they decode it? How do they understand what it says? The process would be careful, methodical, peaceful, because science requires patience. It requires verification. It requires multiple confirmations before anyone can say, "We've made contact." First, scientists would need to verify the signal is real. This means checking everything. Is the equipment working correctly? Could this be interference? Could this be a natural phenomenon we don't understand? Could this be a hoax? Scientists would check all these possibilities. They would be cautious, careful, because false alarms have happened before. If the signal appears to be real, scientists would try to observe it again. They would point other telescopes at the same part of the sky. They would ask observatories around the world to look. They would try to detect the signal from multiple locations. This is called independent verification. It's how science works. One observation isn't enough. Multiple observations are needed, from different places, using different equipment, all confirming the same thing. This process could take weeks, months, even years. Scientists would be patient, careful. They wouldn't rush to announce anything. They would verify, they would confirm, they would be certain before saying anything to the public. But let's imagine the signal is confirmed. Multiple telescopes detect it. It's coming from a specific star system. It's not natural, it's not interference. It appears to be artificial, it appears to be a message. Now comes the challenge of decoding. How do we understand what it says? How do we interpret a message from beings we've never met? From a civilization we know nothing about? This is where mathematics becomes important. Mathematics might be a universal language. The laws of mathematics are the same everywhere. 2 + 2 = 4, whether you're on Earth or on a planet orbiting a distant star. Prime numbers are prime numbers everywhere. The number pi is the same everywhere. In 1974, scientists sent a message from Earth. They used the Arecibo radio telescope in Puerto Rico. They sent a message toward a star cluster called M13. It was about 25,000 light-years away. The message would take 25,000 years to arrive. If anyone is there to receive it, and if they respond immediately, we won't get a reply for 50,000 years. But the message itself was interesting. It was encoded using mathematics. It contained information about our solar system, about Earth, about humans, about DNA. About our number system. It was designed to be decodable by anyone who understands mathematics. The message was a simple image, made of ones and zeros, binary code. It showed our solar system, it showed Earth, it showed a human figure, it showed the structure of DNA, it showed our number system. All encoded in a way that mathematics could decode. If aliens sent us a message, they might do something similar. They might start with mathematics, with prime numbers, with simple patterns, with things that are universal, things that any intelligent species might understand. Prime numbers are particularly interesting. A prime number is only divisible by 1 and itself. 2, 3, 5, 7, 11. 13. These numbers are special. They're the same everywhere. If aliens sent us a sequence of prime numbers, we would recognize it immediately. It would be a clear sign of intelligence, a clear sign of communication. Scientists might look for patterns in the signal, patterns that suggest information, patterns that suggest meaning. They might try different decoding methods. They might look for images, for mathematical concepts, for scientific information, for anything that might convey meaning. The signal might be encoded in binary, ones and zeros, like computer code, or it might use a different number system, base 3, base 8, base 16, or something we haven't imagined. Scientists would try different bases, different encodings, different interpretations. The signal might contain images, encoded as pixels, as data. Scientists would try to reconstruct these images. They might see pictures of their planet, their star system, their biology, their technology, their art. Images would be powerful. They would convey information across language barriers. They would show us what they look like, what their world looks like. The signal might contain sounds, encoded as waveforms, as frequencies. Scientists would try to decode these sounds. They might hear their language, their music, their natural sounds, the sounds of their world. This would be fascinating. It would give us a sense of their culture, their way of experiencing the universe. The signal might contain scientific information, mathematical formulas, physical constants, chemical structures, biological information. Things they've learned about the universe, things they want to share. This would be incredibly valuable. It would advance our understanding. It would accelerate our learning. The signal might contain instructions, how to build something, how to understand something, how to communicate back. This would be practical. It would help us respond. It would help us build a relationship. Scientists would use computers, artificial intelligence, machine learning, to help decode, to find patterns, to understand structure, to interpret meaning. This would be a collaborative effort, humans and machines working together, to understand a message from another world. But here's something important to understand. We might not be able to decode it. The message might be too complex. It might use concepts we don't understand. It might be designed for a species with different senses, different ways of thinking, different understanding of the universe. We might receive a message and never understand what it says. We might know it's from aliens. We might know it contains information, but we might not be able to decode it. And that's okay. The fact that we received it would be enough. The fact that we're not alone would be enough. But let's imagine we can decode it. What might it say? What information would aliens send first? They might send basic information about themselves, about their planet, about their star system, about their biology, about their civilization. They might send scientific knowledge, things they've learned about the universe, things they want to share. They might send warnings about dangers in the universe, warnings about mistakes they've made, warnings about things to avoid. They might send art, music, images, things that express who they are, things that show their culture, their values, their way of seeing the universe. They might send questions about us, questions about our world, questions about our understanding of the universe. We don't know, we can only imagine, but the process of trying to decode would be fascinating. It would require patience, it would require creativity, it would require cooperation. Scientists from around the world would work together. Mathematicians, linguists, computer scientists, astronomers, all trying to understand, all trying to decode, all trying to make sense of a message from another world. There's another possibility. We might not receive an intentional message at all. We might detect their signals accidentally. Their radio broadcasts, their television signals, their communication with each other, signals not meant for us, signals we just happen to intercept. For over a century, Earth has been broadcasting radio signals, television signals, all traveling outward at light speed, creating what scientists call a radiosphere, a sphere of our signals expanding into space. Any civilization within that sphere could potentially detect us, if they have the right technology, if they're listening. But here's something interesting. Research suggests that unless civilizations are extremely abundant, the probability of contact remains low, until humanity reaches what's called the contact era. This might be several hundred years from now, or a few thousand years. It depends on how common civilizations are, how far apart they are, how long they last. The contact era would be when our signals have spread far enough, when enough time has passed, when the probability of contact becomes significant. We're not there yet, but we're getting closer. Every year, our radiosphere expands. Every year, more of space can potentially detect us. Every year, we move closer to the contact era. But we might also detect them first. We might intercept their signals, their broadcasts, their communications. We might learn about them before they know about us. This would be peaceful. It would give us time to prepare, to think, to decide how to respond. Or they might detect us first. They might have been listening longer. They might have better technology. They might have detected our signals decades ago, or centuries ago. They might already know we're here. They might already be trying to communicate. Their messages might be on the way, traveling through space, getting closer every day. We don't know. We can only wait. Listen, search, hope. The process is peaceful. It requires patience. It requires wonder. There's another important thing to consider: time delays. If the signal comes from a star 100 light-years away, it took 100 years to arrive. The message might be 100 years old. By the time we receive it, that civilization might have changed. They might have evolved. They might have moved on. They might not even exist anymore. Or they might be much older, much more advanced. The message might be from a civilization that's been around for thousands of years, for millions of years. They might be so advanced that we can barely understand them. They might be trying to communicate with us, but we might be like children trying to understand adults. This is part of what makes the process peaceful. It's not urgent, there's no rush. The message has been traveling for years, for decades, for centuries. A few more years to decode it won't matter. The patience required is calming. The careful work is meditative. The Arecibo message we sent in 1974 is still traveling. It won't reach its destination for another 24,000 years. If anyone receives it and responds immediately, we won't get a reply for 50,000 years. By then humanity might be completely different. We might have evolved. We might have spread across the galaxy. We might not even exist anymore. But the message is still traveling, still carrying information about who we were, about what we knew, about what we hoped. It's a message in a bottle, tossed into the cosmic ocean, hoping someone will find it, hoping someone will understand. The message was designed by Frank Drake and Carl Sagan. It was a simple image, made of ones and zeros, binary code. It showed our number system, 1 through 10. It showed the atomic numbers of key elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, the building blocks of life. It showed the structure of DNA, the double helix. It showed a human figure. It showed our solar system, with Earth highlighted. It showed the Arecibo telescope itself, the instrument that sent the message. The message was sent as a single transmission. It lasted about 3 minutes. It was aimed at M13, a globular star cluster, about 25,000 light-years away. It contains hundreds of thousands of stars. The chances that anyone is there to receive it are small. But the message is still traveling, still carrying our hopes, still representing humanity, as we were in 1974. As we hoped to be understood. We've sent other messages too, the Pioneer plaques, attached to the Pioneer 10 and 11 spacecraft. They show a man and a woman. They show our location relative to pulsars. They show our solar system. They're still traveling beyond our solar system, into interstellar space. The Voyager Golden Records, 2 phonograph records, made of gold, carried by Voyager 1 and 2. They contain sounds and images, greetings in 55 languages, music from around the world, sounds of nature, images of Earth, images of humans, images of our technology, our art, our science. They're still traveling, still carrying our message, still representing humanity. All of these messages are peaceful. They're not aggressive, they're not threatening, they're invitations. Invitations to communicate, invitations to connect. They represent our best qualities, our curiosity, our wonder, our desire to reach out, our hope that we're not alone. If we receive a message, it might be the same, a message sent long ago, by a civilization that might not exist anymore, but the message itself would be precious. It would tell us we're not alone. It would tell us that intelligence exists elsewhere. It would change everything. The process of decoding would be slow, careful, patient. Scientists would work together. They would share ideas. They would try different approaches. They would be methodical. They would be thorough. Because this might be the most important message humanity ever receives. Teams would form around the world. Mathematicians would analyze patterns. Computer scientists would develop algorithms. Linguists would look for language structures. Artists would help visualize possibilities. Everyone would contribute. Everyone would help. This would be a global effort, a human effort, a peaceful effort. The work would be published, papers would be written, conferences would be held. Ideas would be shared. Progress would be made slowly, gradually, patiently. But it would be made. Understanding would grow. Piece by piece. Bit by bit. Until eventually we might understand. We might decode. We might know what they're saying. But even if we never fully decode it, the attempt would be valuable. It would teach us about communication, about information, about the challenges of understanding. It would bring humanity together. It would show our best qualities, our curiosity, our persistence, our desire to understand. The process itself would be peaceful. There would be no rush, no urgency, just careful, patient work. Just the wonder of trying to understand. Just the beauty of the attempt. The decoding would also be collaborative. Scientists from different countries would work together. They would share data, they would share ideas, they would share progress. This collaboration would be beautiful. It would show humanity working together. It would show our best qualities, our curiosity, our persistence, our desire to understand. The public would also be involved. People would follow the progress. They would learn about the challenges, they would understand the complexity, they would appreciate the effort. This engagement would be valuable. It would help people understand. It would help them appreciate. It would help them wonder. The decoding might take years, decades, even centuries, but the attempt would be worth it. The learning would be worth it. The understanding would be worth it. Even partial understanding would be valuable. Even knowing that we're not alone would be enough. Even the attempt would be beautiful. The challenges would be significant. The message might use concepts we don't understand. It might reference things we've never seen. It might use logic we can't follow. But these challenges would be part of the learning. They would push us to think differently, to understand differently, to grow. The process would also be educational. We would learn about communication, about information theory, about the challenges of understanding. We would learn about ourselves, about our limitations, about our capabilities. This learning would be valuable. It would help us grow. It would help us understand. The process would also bring people together. Scientists from different fields, people from different countries, people from different backgrounds, all working together, all trying to understand, all hoping. This unity would be beautiful. It would show humanity at its best, working together, hoping together, wandering together. As we continue our journey, we'll explore what happens after we decode the message, how humanity might respond, how the world might change. But always remember, the process itself is beautiful. The careful verification, the patient decoding, the wonder of receiving a message from another world. The journey from signal to understanding is a long one. It requires patience, it requires care, it requires wonder. But it's a journey worth taking. A message worth decoding. A connection worth making. So as we drift deeper into this exploration, keep in mind that receiving a signal will be just the beginning. The real work would be understanding it, decoding it, making sense of a message from beings we've never met, from a civilization we know nothing about. But the process would be peaceful, patient, full of wonder. To understand this fully, we need to explore the vast distances involved, the time delays, the cosmic scales that make interstellar communication so challenging. Chapter 3: The Distance Problem. Light speed and time. If we receive a signal from an alien civilization, one thing is certain: they are far away. Very far away. The distances in space are almost unimaginable. And these distances create challenges. Beautiful challenges. Peaceful challenges. But challenges nonetheless. Let's start with something familiar. The Sun. Our Sun is about 93 million miles away. That's far. But light travels fast. Very fast. Light from the Sun takes about 8 minutes to reach Earth. 8 minutes. That's manageable. We can communicate with spacecraft near the Sun, with only a short delay. But the nearest star to our Sun is Proxima Centauri. It's about 4.2 light-years away. A light-year is the distance light travels in 1 year. It's about 6 trillion miles. 6 trillion. That's a 6 followed by 12 zeros. It's an almost unimaginable distance. If there's a civilization around Proxima Centauri, and they send us a signal, it will take 4.2 years to arrive. 4.2 years. That means if they send a message today, we won't receive it until 2028. and if we respond immediately, they won't receive our reply until 2032. A simple conversation would take over 8 years. But Proxima Centauri is close, very close. Most stars are much farther away. The center of our galaxy is about 26,000 light-years away. If a civilization there sends us a message, it took 26,000 years to arrive. 26,000 years ago, humans were just beginning to develop agriculture. We were living in small groups. We hadn't invented writing yet. We were just starting to build civilizations. If we receive a message from the center of the galaxy, it might be from a civilization that sent it when humans were still hunter-gatherers. By the time we receive it, that civilization might be gone. They might have evolved beyond recognition. They might have moved on. They might not even exist anymore. This is part of what makes interstellar communication peaceful. It's not urgent, there's no rush. Messages take years to travel, decades, centuries, millennia. A few more years to respond won't matter. The patience required is calming. The long view is meditative. Light speed is the ultimate speed limit. Nothing can travel faster than light. Not matter, not information, not messages. Light speed is constant. It's about 186,000 miles per second. That's fast. Incredibly fast. But space is vast. Incredibly vast. So even at light speed, messages take a long time to travel. This creates interesting situations. We might receive a message from a civilization that no longer exists. We might send a message to a civilization that doesn't exist yet. We might be having conversations with civilizations across thousands of years, across the rise and fall of empires, across the evolution of species. Imagine this. A civilization 1,000 light-years away sends us a message. It takes 1,000 years to arrive. We receive it. We decode it. We understand it. We respond. Our response takes another 1,000 years to reach them. By the time they receive our reply, 2,000 years have passed. 2,000 years. That's longer than the Roman Empire lasted. Longer than most civilizations last. This means interstellar communication is fundamentally different from Earth communication. On Earth, we can have real-time conversations. We can ask questions and get immediate answers. We can have back-and-forth discussions. But across interstellar distances, conversations span generations. They span centuries. They require patience that's almost unimaginable. But this patience is peaceful. It's calming. It's meditative. There's no rush, no urgency, just the slow, patient exchange of information across the vastness of space. There's another interesting aspect of time and distance. Relativity. Einstein's theory of relativity tells us that time passes differently depending on how fast you're moving. If you travel very fast, time passes more slowly for you. This is called time dilation. The effect becomes significant only at very high speeds. At everyday speeds it's negligible. But as you approach light speed, time dilation becomes dramatic. If you could travel at 99% of light speed, time would pass about 7 times slower for you than for someone at rest. A journey that takes 7 years for you would take about 1 year for observers on Earth. But for interstellar communication, this effect is small. Unless we're traveling at nearly the speed of light, time dilation doesn't matter much. For messages traveling at light speed, time passes normally. The main challenge is just the distance, the vast distances that make communication slow. There's also the concept of simultaneity. In relativity, events that appear simultaneous to one observer might not appear simultaneous to another. If 2 events happen at the same time according to someone on Earth, they might happen at different times, according to someone moving at high speed. This adds complexity to interstellar communication. But for practical purposes, the main challenge is still just the vast distances. the time it takes for light to travel, the patience required. The speed of light is constant, it's the same for everyone, no matter how fast you're moving, no matter where you are. This is one of the fundamental principles of relativity. It means that light speed is a universal constant, a fundamental limit. Nothing can travel faster than light. Not matter, not information, not messages. This is why interstellar communication takes so long. This is why patience is essential. Physical travel is even more challenging. If we wanted to visit Proxima Centauri, even at light speed, it would take over 4 years. But we can't travel at light speed. Our fastest spacecraft travel at a tiny fraction of light speed. The Voyager spacecraft, launched in 1977, travel at about 38,000 miles per hour. That's fast by Earth standards. But it's only about 0.006% of light speed. At that speed, it would take over 70,000 years to reach Proxima Centauri. To travel to other stars in reasonable time, we would need much faster speeds. We would need to approach light speed. But as you approach light speed, strange things happen. Time dilation becomes significant. The energy required becomes enormous. The physics becomes challenging. The engineering becomes nearly impossible with current technology. Some have proposed generation ships, massive spacecraft that would travel for thousands of years, carrying entire populations. People would be born, live, die, all during the journey. Their descendants would arrive at the destination. This is theoretically possible, but it would require enormous resources, enormous commitment. Generations of people willing to live their entire lives in transit. Others have proposed faster methods, using nuclear propulsion, using antimatter, using theoretical concepts like warp drives. But these are far beyond our current capabilities. They might be possible, but they're not possible yet. This is why communication might be easier than travel. We can send messages at light speed. We can't travel at light speed. So we might communicate with civilizations we'll never visit. We might exchange knowledge with beings we'll never meet. We might build relationships across distances that physical travel can't bridge. But contact might inspire us to try, to develop new technologies, to push the boundaries, to find ways to travel faster, to make the journey possible. This inspiration would be peaceful. It would be hopeful. It would drive us forward. But it would also require patience, because these technologies might take centuries to develop, or millennia, or they might never be possible. We don't know. But the attempt would be beautiful. The effort would be worthwhile. The cosmic calendar helps us understand these timescales. Imagine the entire history of the universe compressed into 1 year. The Big Bang happens on January 1st. Our solar system forms in early September. Life on Earth begins in late September. Dinosaurs appear in mid-December. Humans appear in the last few minutes of December 31st. All of human history happens in the last few seconds. On this cosmic calendar, if we receive a message from a civilization 1,000 light-years away, that message was sent about 1,000 years ago. On the cosmic calendar, that's still December 31st. Still very recent, still part of the same cosmic moment. But if we receive a message from the center of the galaxy, it was sent 26,000 years ago. On the cosmic calendar, that's still December 31st. Still recent in cosmic terms. But in human terms, it's ancient. It's from before agriculture, before civilization, before writing. This perspective is peaceful. It reminds us that we're all part of the same cosmic moment, that civilizations across the galaxy might be experiencing the same cosmic time, that we're all exploring the universe together, even if we're separated by vast distances. even if we'll never meet. The cosmic calendar also helps us understand the scale of life. On this calendar, life on Earth began in late September. That's about 3.8 billion years ago. Life has existed for most of Earth's history. But intelligent life? That's only been around for the last few seconds. On the cosmic calendar, human civilization is incredibly recent. We're just beginning. For most of Earth's history, life was simple, single-celled organisms. Then multicellular life appeared. Then complex organisms. Then intelligence. This progression took billions of years. It required countless chance events. It required the right conditions, the right timing, the right circumstances. On other worlds, this progression might have happened faster, or slower, or differently. Some worlds might have developed intelligence billions of years ago. Others might develop it billions of years from now. The timing is crucial. For two civilizations to communicate, they need to exist at the same time. They need to be close enough. They need to have the right technology. This is part of the challenge. The universe is old, billions of years old. But intelligent civilizations might be rare. They might be short-lived. They might be separated by vast distances. The chances of overlap are small, but not zero. The search continues. Because the possibility exists. Because wonder exists. Because hope exists. If other civilizations exist, they might be at similar stages. They might have just developed intelligence. They might be just beginning to explore. They might be just starting to search. Or they might be much older. They might have existed for millions of years. They might be far more advanced. But on the cosmic calendar, even millions of years is recent. Even the oldest civilizations would be part of the same cosmic moment. The same cosmic story. This perspective is calming. It reminds us that we're all part of something larger, that we're all exploring together, that we're all part of the same cosmic journey. Even if we're separated by vast distances, even if we'll never meet, we're still connected by the same cosmic time, by the same cosmic story, by the same cosmic wonder. The vastness of space is not frightening, it's peaceful, it's calming. It reminds us of our place in the cosmos. We're small, but we're part of something vast. Something beautiful, something that connects us to civilizations we've never met, to beings we've never imagined. As we continue our journey, we'll explore what those beings might be like, what alien life might look like, how civilizations might evolve. But always remember, the vast distances are peaceful, the time delays are calming, the patience required is meditative. The journey from one star to another is long. It takes time, it requires patience, but it's a journey worth taking, a connection worth making, a conversation worth having, even if it spans generations, even if it spans centuries, even if we'll never meet. So as we drift deeper into this exploration, keep in mind that distance is not a barrier, it's a challenge. A beautiful challenge. A peaceful challenge. One that requires patience, one that requires wonder, one that connects us to the vastness of the cosmos. To understand first contact fully, we need to imagine what those distant civilizations might be like, what alien life might look like, how intelligence might evolve elsewhere. Chapter 4: What are they like? The science of alien life. If we make contact with an alien civilization, one of our first questions would be, what are they like? What do they look like? How do they think? How do they live? What is their world like? We can't know for sure, we can only imagine, but we can use science to guide our imagination. We can use what we know about life on Earth, we can use what we know about physics and chemistry, we can use what we know about evolution to imagine what might be possible, what might be likely, what might exist elsewhere. Let's start with what we know about life. Life on Earth is based on carbon. Carbon atoms can form complex molecules. They can form chains, they can form rings, they can form structures of incredible complexity. DNA is made of carbon-based molecules. So are proteins. So are all the molecules that make life possible. But could life be based on something else? Some scientists have imagined silicon-based life. Silicon is similar to carbon. It's in the same column of the periodic table. It can form some complex molecules. But silicon-based life would be very different from carbon-based life. It would need different temperatures, different environments, different chemistry. We don't know if silicon-based life is possible. We've never found it. All life on Earth is carbon-based. But the universe is vast. The possibilities are endless. Maybe somewhere silicon-based life exists. Maybe somewhere life is based on something we haven't even imagined. What we do know is that life needs certain things. It needs energy, it needs materials, it needs an environment where complex molecules can form and persist. On Earth, life needs liquid water. Water is an excellent solvent. It can dissolve many substances. It can facilitate chemical reactions. It's essential for life as we know it. But maybe life elsewhere doesn't need water. Maybe it uses liquid methane, or liquid ammonia, or some other liquid we haven't imagined. The possibilities are vast. The universe is full of different environments, different conditions, different possibilities for life. On Earth, we've discovered life in impossible places. We call these organisms extremophiles. They live in environments we thought were too harsh for life. Some live in boiling water. Some live in freezing temperatures. Some live in highly acidic conditions. Some live deep underground. Some live in the deepest parts of the ocean, under incredible pressure. These extremophiles show us that life is resilient, that it can adapt to extreme conditions, that it might exist in places we haven't even imagined. If life can exist in these extreme environments on Earth, maybe it can exist in extreme environments elsewhere. On planets we thought were too hot, too cold, too harsh, too different from Earth. The search for life elsewhere focuses on what we call biosignatures, signs that life exists. These might be chemicals in an atmosphere. Like oxygen. On Earth, most oxygen comes from life. Plants produce it through photosynthesis. If we detect oxygen in another planet's atmosphere, it might be a sign of life. Or methane. Methane can be produced by life. On Earth, many organisms produce methane. If we detect methane on another planet, especially along with other signs, it might indicate life. Or we might look for technosignatures, signs of technology, signs of advanced civilizations, like radio signals, or laser signals, or structures around stars, or atmospheric pollution from industry. These would tell us not just that life exists, but that intelligent, technological civilizations exist. We've discovered thousands of exoplanets. Planets orbiting other stars. The first was discovered in 1995. Since then, we've found thousands more. Some are in the habitable zone. The zone where liquid water could exist. Where life as we know it might be possible. The James Webb Space Telescope is now analyzing these exoplanets. It's looking at their atmospheres, searching for biosignatures, chemicals that might indicate life, oxygen, methane, other gases that life might produce. It's a peaceful search, a patient search, but it's bringing us closer to finding life elsewhere. The telescope uses spectroscopy. It analyzes the light from stars as it passes through exoplanet atmospheres. Different chemicals absorb different wavelengths of light. By studying these absorption patterns, scientists can determine what gases are present. They can look for signs of life. Signs of technology. Signs of civilization. Already the telescope has found interesting things. Water vapor in some atmospheres, carbon dioxide, other compounds. These are building blocks. They're necessary for life, but they're not proof of life. Not yet. But the search continues, patiently, peacefully, with wonder and hope. Future telescopes will be even more powerful. They'll be able to detect smaller signals. They'll be able to analyze more exoplanets. They'll be able to search more thoroughly. The search will continue. It will improve. It will expand. And maybe, someday, we'll find something. Maybe we'll detect biosignatures. Maybe we'll detect technosignatures. Maybe we'll find proof that we're not alone. Some exoplanets are very different from Earth. Some are much larger. Super-Earths. Planets several times the mass of Earth. They might have thicker atmospheres, stronger gravity, different conditions. Some are much smaller. Mini-Neptunes. Gas planets smaller than Neptune. They might have different compositions, different structures. Some orbit very close to their stars. They complete orbits in days, or even hours. They're scorching hot, but maybe life could exist there, in different forms. Adapted to extreme heat. Some orbit very far away. They take years to complete an orbit. They're freezing cold. But maybe life could exist there too, adapted to extreme cold. Some might have conditions we can't imagine. Planets with multiple suns. Planets with no suns. Rogue planets drifting through space. Planets with exotic chemistries. Planets with different physics. The possibilities are endless. The diversity is beautiful. It shows us how many possibilities there are. How many different worlds might exist. How many different forms life might take.
The universe is full of variety.
Full of possibility. Full of wonder. Each exoplanet we discover is a new possibility. A new world. A new chance for life. A new chance for intelligence. A new chance for civilization. Each discovery brings us closer. Closer to understanding. Closer to finding. Closer to connection. But what would those civilizations be like? How would they evolve? How would they think? On Earth, intelligence evolved gradually. Simple organisms became more complex. They developed nervous systems. They developed brains. They developed the ability to learn, to remember, to plan, to communicate, to use tools, to build civilizations. But intelligence might not be inevitable. It might be rare. It might require specific conditions. It might require a long evolutionary history. It might require challenges that push organisms to become smarter. We don't know. We only have one example, us. But we can look at convergent evolution. This is when similar traits evolve independently in different species. On Earth, eyes have evolved many times. In fish, in insects, in mammals, in many different groups. Because vision is useful. Because it solves a common problem. Flight has also evolved multiple times. In birds, in bats, in insects, in pterosaurs. Different solutions to the same problem. Different paths to the same goal. This suggests that certain traits are advantageous. That evolution finds similar solutions when faced with similar challenges. Maybe intelligence is like that. Maybe it evolves whenever conditions are right. Maybe it's a solution to the problem of survival. Maybe it's more common than we think. On Earth we see intelligence in many forms. In dolphins, in elephants, in octopuses, in corvids. Different kinds of intelligence, different ways of thinking. But all solving similar problems. All adapting to their environments. Or maybe intelligence is rare. Maybe Earth is special. Maybe intelligence requires such specific conditions that it almost never happens. Maybe it requires a long evolutionary history. Maybe it requires specific environmental pressures. Maybe it requires chance. We don't know. We only have one example, us. But we can look at what intelligence requires. On Earth, intelligence seems to require complex nervous systems, large brains relative to body size, social structures, communication, tool use. These things might be necessary. Or they might just be one path, one way intelligence could evolve. On other worlds, intelligence might take different forms. It might be based on different senses. It might use different forms of communication. It might think in ways we can't imagine. It might solve problems we haven't thought of. The possibilities are vast. The universe is full of variety, full of different paths, full of different solutions. We don't know, we can only imagine, but the imagining is peaceful. It's full of wonder, it's full of possibility. If intelligence does evolve elsewhere, what would those intelligent beings be like? They might be very different from us, they might have different senses, they might perceive the world differently, they might think differently, they might have different values, different goals, different ways of understanding the universe. Or they might be surprisingly similar. They might have evolved to solve similar problems. They might have developed similar technologies. They might have similar curiosity, similar wonder, similar desire to explore, to understand, to connect. We don't know, but we can imagine, and imagining is peaceful. It's calming, it's full of wonder. Some scientists have tried to classify civilizations by their level of technology. This is called the Kardashev scale, named after Russian astronomer Nikolai Kardashev. He proposed this scale in 1964. It's a way of thinking about how advanced a civilization might be, based on how much energy they can use. A Type 1 civilization can use all the energy available on their planet. They can harness solar energy, wind energy, geothermal energy, all the energy their planet receives from its star. Humanity is not quite Type 1 yet. We're estimated to be around Type 0.7. We're getting close. But we're not there yet. A Type 1 civilization would have complete control over their planet's climate. They could prevent natural disasters. They could manage their environment perfectly. They would be masters of their world. A Type 2 civilization can use all the energy from their star. They might build structures around their star, like a Dyson sphere, a hypothetical structure that surrounds a star and captures its energy. This would be enormous. It would require materials from entire planets. It would require technology far beyond ours. But it's theoretically possible. A Type 2 civilization would have energy beyond imagination. They could travel between stars. They could terraform planets. They could reshape solar systems. A Type 3 civilization can use the energy of an entire galaxy. They might have spread across thousands of star systems. They might have technology we can barely imagine. They might be so advanced that we can't understand them. A Type 3 civilization would be like gods to us. Their capabilities would seem magical. They might have existed for millions of years. They might have solved problems we haven't even thought of yet. Some have proposed even higher types. Type 4 civilizations that control entire galaxy clusters. Type 5 civilizations that control the universe itself. But these are purely speculative. We can barely imagine. Type 3, Type 4 and V are beyond comprehension. If we make contact, what type of civilization might they be? They might be Type 1 like us, just beginning to explore space, just beginning to search for other civilizations. They might be curious. They might be hopeful. They might be wondering if they're alone. Communication with them would be easier. We'd be at similar levels. We'd understand each other better. Or they might be Type 2. much more advanced. They might have been exploring space for thousands of years. They might have visited many star systems. They might have technologies we can't imagine. They might be trying to help younger civilizations. Or they might be indifferent to us. Communication might be challenging. They might be trying to communicate with us, but we might struggle to understand. Or they might be Type 3, so advanced that we can barely understand them. They might have existed for millions of years. They might have spread across the galaxy. They might be so different from us that communication is almost impossible, but they might still try. They might have patience. They might understand that younger civilizations need time to grow, to learn, to understand. We don't know. But the possibility is fascinating. The wonder is calming. The imagination is peaceful. Whatever type they are, contact would be significant. It would change everything. It would open new possibilities. It would connect us to something larger. It would be beautiful. It would be peaceful. It would be full of wonder. What we do know is that if we make contact, those beings would have evolved. They would have a history. They would have faced challenges. They would have solved problems. They would have learned. They would have grown, just like us. They might be very different, but they might also share something fundamental: curiosity, wonder. The desire to understand. The desire to explore. The desire to connect. These might be universal. These might be what intelligence brings, wherever it exists. As we continue our journey, we'll explore how humanity might respond to contact, how the world might change. But always remember, those distant beings, whatever they're like, would be part of the same cosmic story, part of the same universe, part of the same search for understanding. The journey from imagining to knowing is long. It might never happen. But imagining is peaceful, it's calming, it's full of wonder. So as we drift deeper into this exploration, keep in mind that alien life, whatever it's like, would be part of the cosmic community, part of the vast network of life, part of the beautiful diversity of the universe, different, but connected, separate, but part of something larger. To understand first contact fully, we need to explore how humanity might respond, how the world might change, how we might adapt to the knowledge that we're not alone. Chapter 5: The Response: How Humanity Would React. Imagine the moment. Scientists have verified the signal. They've confirmed it's from an alien civilization. They've decoded at least part of it. They understand what it means. Now comes the question: how do we tell the world? How do we announce the greatest discovery in human history? There are protocols for this, not official government protocols, not international laws, but guidelines created by scientists, guidelines for how to handle the detection of extraterrestrial intelligence. These protocols have been developed over decades. They've been discussed at international conferences. They've been refined by scientists around the world. The first step would be verification. Scientists would need to be absolutely certain. They would check everything. Is the equipment working correctly? Could this be interference from Earth? Could this be a natural phenomenon? Could this be a hoax? Every possibility would be examined. Every alternative explanation would be considered. Scientists would be cautious, careful, because this is too important to get wrong. The verification process would be thorough. Multiple telescopes would observe the signal from different locations, using different equipment. Scientists would analyze the signal's characteristics, its frequency, its strength, its pattern, its source direction. Everything would be checked. Everything would be verified. Once verified, scientists would likely inform other scientists first. They would share the data. They would ask for independent confirmation. They would follow the scientific method: peer review, verification, confirmation. This process could take weeks, months, even years. There would be no rush, no urgency. Just careful, methodical verification. During this time, the discovery would likely remain confidential. Scientists would work quietly. They would verify. They would confirm. They would be certain before saying anything publicly. This secrecy wouldn't be about hiding. It would be about being careful, about being certain, about following proper scientific procedure. But eventually the news would get out. It might leak, or scientists might decide to make a formal announcement. However it happens, the world would learn. Humanity would discover that we're not alone. How would people react? This is hard to predict, but we can look at history. We can look at how people have reacted to major discoveries, to paradigm shifts, to news that changes everything. When Copernicus proposed that Earth orbits the Sun, not the other way around, it was revolutionary. It changed how people understood their place in the universe. Some people accepted it immediately, some resisted, some were afraid. But eventually, humanity adapted. We learned to see ourselves as part of a larger system, not the center of everything. When Galileo discovered that Jupiter has moons, it showed that other worlds exist, that Earth is not unique. Some people were excited. Some were concerned. Some were afraid. But humanity adapted. We learned that we're part of a larger cosmos. When Hubble discovered that the universe is expanding, that there are billions of galaxies, it changed everything again. We learned that our galaxy is just one of many. That we're smaller than we thought, but also part of something larger, more beautiful, more vast. Each of these discoveries was a paradigm shift. Each changed how we see ourselves. Each required humanity to adapt, to grow, to understand our place in the universe differently. First contact would be the biggest paradigm shift of all. It would tell us we're not alone, that intelligence exists elsewhere, that we're part of a cosmic community, that the universe is full of life, full of intelligence, full of possibility. How would people react? Some would be excited, thrilled, filled with wonder. They would see it as proof that the universe is full of life, that we're part of something larger, that there's hope, that there's connection. Some would be afraid, concerned, worried about what this means, worried about what aliens might want, worried about how this changes everything. This fear would be understandable. Change is scary. The unknown is frightening. Some would be skeptical. They would want more proof. They would question everything. They would need time to process. This skepticism would be healthy. It would ensure we verify everything carefully. Some would see it through a religious lens. Some religions might see it as confirmation of their beliefs. Others might see it as a challenge. Religious leaders would need to help people understand, to adapt, to see this as part of a larger cosmic story. Some would see it through a scientific lens. They would be excited about the possibilities, about what we might learn, about how this advances our understanding of the universe. Governments would need to respond. They would need to coordinate, to decide who speaks for Earth, to decide how to respond, to decide what to share. This would require international cooperation, something that's often difficult. But this might be the moment that brings humanity together, the moment we realize we're all in this together, that we're all part of Earth, that we need to work together. The media would play a crucial role. How they present the news would shape how people react. If they present it calmly, scientifically, it would help people adapt. If they present it sensationally, fearfully, it might cause panic. The responsibility would be great. Scientists would be at the center. They would need to explain, to educate, to help people understand. They would need to be patient, to answer questions, to help humanity process this discovery. The announcement itself would be historic. It would be broadcast around the world. It would be translated into every language. It would be shared everywhere. Billions of people would learn at the same time that we're not alone, that intelligence exists elsewhere, that the universe is full of possibility. The announcement would likely come from scientists, from astronomers, from SETI researchers. They would explain what was found, how it was verified, what it might mean. They would be careful, they would be clear, they would be honest about what we know, and what we don't know. World leaders might also speak. They might address their nations. They might call for unity. They might call for cooperation. They might call for calm. This would be important. It would help people process. It would help prevent panic. It would help humanity come together. The media would cover it extensively. Every news outlet, every channel, every platform. The story would be everywhere. People would talk about it, they would think about it, they would wonder about it. It would dominate conversations for days, for weeks, for months. Social media would explode. People would share their thoughts, their reactions, their hopes, their fears. The conversation would be global, it would be immediate. It would be profound. Everyone would be part of it. Everyone would be affected by it. But through it all there would be a sense of wonder, a sense of possibility, a sense of connection to something larger, to the cosmos, to the universe, to the possibility that we're not alone. In the days and weeks after the announcement, people would process, they would talk, they would think, they would wonder, they would adapt, slowly, gradually. Humanity would come to terms with this new reality. The initial reaction would be mixed. Some people would be excited immediately. They would see it as proof of life in the universe, as confirmation of their beliefs, as hope for the future. They would celebrate. They would share the news. They would want to learn more. Some people would be afraid. They would worry about what this means. They would worry about what aliens might want. They would worry about invasion, about destruction, about change. This fear would be understandable. Change is scary. The unknown is frightening. But it would also be manageable. Because the contact would be distant, because there would be time, because we would have control over our response. Some people would be skeptical. They would want proof. They would question everything. They would need time to process. This skepticism would be healthy. It would ensure we verify everything carefully. It would prevent panic. It would keep us grounded. Religious communities would need to adapt. Some religions might see contact as confirmation of their beliefs. Others might see it as a challenge. Religious leaders would need to help their communities understand, to see contact as part of a larger cosmic story, to integrate this discovery into their worldview. Scientists would be at the center. They would need to explain, to educate, to help people understand. They would hold press conferences. They would write articles. They would appear on television. They would answer questions. They would help humanity process this discovery. The media would play a crucial role. How they present the news would shape how people react. If they present it calmly, scientifically, it would help people adapt. If they present it sensationally, fearfully, it might cause panic. The responsibility would be great. The impact would be profound. Over time, people would adapt. They would come to accept this new reality. They would integrate it into their worldview. They would see themselves differently. As part of a cosmic community, as part of something larger, this adaptation would be peaceful. It would be gradual. It would be beautiful. Some things might change immediately. Space exploration might get more funding, more interest, more support. People might see the value in exploring, in reaching out, in being part of the cosmic community. Governments might increase space budgets. They might fund new missions. They might build new telescopes. They might develop new technologies. The public might support this. They might see space exploration as essential, as important, as necessary. Private companies might also invest more. They might see opportunities, they might see value. They might want to be part of this new era, this new chapter in human history. Science education might become more important. People might want to understand, to learn, to be part of this discovery, to understand what it means. Schools might emphasize science more. They might teach about SETI, about astronomy, about the search for life. Students might be more interested. They might see science as relevant, as exciting, as important. Universities might expand their programs. They might offer more courses in astrobiology, in SETI, in interstellar communication. Students might flock to these programs. They might want to be part of the search. They might want to contribute. International cooperation might improve. Countries might work together more. They might see the value in unity, in speaking with one voice, in representing Earth as one planet, one species, one civilization. The United Nations might play a role. It might coordinate responses. It might help decide who speaks for Earth. It might facilitate cooperation. It might help humanity work together. International space agencies might collaborate more. NASA, ESA, Roscosmos, CNSA, JAXA. They might work together. They might share resources. They might coordinate efforts. They might represent Earth as one. This cooperation would be peaceful. It would be voluntary. It would be based on shared interest, on shared wonder, on shared hope. It would show humanity at its best. Working together, exploring together, hoping together. Some things might not change at all. Daily life would continue. People would still go to work, still care for their families, still live their lives. But with a new perspective, a new understanding, a new sense of our place in the universe. The long-term impact would be profound. Over years, over decades, over generations, humanity would adapt, we would grow, we would understand ourselves differently. We would see ourselves as part of a cosmic community, not alone, not isolated, but connected, part of something larger. This adaptation would be peaceful. It would be gradual. It would require patience, but it would be beautiful. It would show humanity's ability to grow, to adapt, to understand, to connect. As we continue our journey, we'll explore how communication might begin, how we might respond, how we might build a relationship across vast distances. But always remember, the response itself would be peaceful, careful, thoughtful, full of wonder. The journey from discovery to adaptation is long. It requires patience. It requires care. It requires humanity to work together, but it's a journey worth taking, a discovery worth making, a connection worth building. So as we drift deeper into this exploration, keep in mind that humanity's response would be careful, thoughtful, peaceful. It would require cooperation. It would require patience. It would require wonder. But it would also be beautiful. It would show our best qualities, our curiosity, our ability to adapt, our desire to connect. To understand first contact fully, we need to explore how communication might begin, how we might respond to their message, how we might build a dialogue across the vastness of space. Chapter 6: Communication begins. Building a dialogue. Once we've received a signal, once we've verified it, once we've decoded it at least partially, once humanity has processed the news, then comes the next question. How do we respond? What do we say? What do we share? How do we begin a conversation that will span light years and centuries? This is not a simple question. It's not like sending an email or making a phone call. This is sending a message into the cosmos. A message that will take years to arrive, decades, centuries. A message that represents humanity, that represents Earth, that represents who we are. What should we say? What information should we share? What should we ask? These are profound questions. Questions that would require careful thought, careful consideration, careful planning. We might start with mathematics. As we discussed earlier, mathematics might be a universal language. We might send prime numbers, simple patterns, things that any intelligent species might understand. Things that say, we are here, we understand mathematics, we are trying to communicate. The Voyager Golden Records are examples of what we've already sent. In 1977, the Voyager spacecraft were launched. They carried golden records, phonograph records made of gold. They contained sounds and images selected to portray the diversity of life and culture on Earth. They included greetings in 55 languages, music from different cultures, sounds of nature, images of Earth, images of humans, images of our technology, our art, our science. These records are still traveling. They're now beyond our solar system, in interstellar space. They'll continue traveling for billions of years. They might be found someday. By someone, by something. They represent humanity, who we were, what we knew, what we hoped. If we were to send a message in response to contact, we might include similar things. Information about ourselves, about Earth, about our solar system, about our biology, about our civilization. We might send images, sounds, music, art, things that express who we are, things that show our culture, our values, our way of seeing the universe. We might send scientific knowledge, things we've learned about the universe, about physics, about chemistry, about biology, things we want to share, things we hope might be useful. We might send our understanding of mathematics, our discoveries in science, our theories about how the universe works. We might send questions about them, about their world, about their understanding of the universe. Questions that show our curiosity, our wonder, our desire to learn. We might ask about their biology, their technology, their history, their understanding of the cosmos. We might send warnings, warnings about mistakes we've made, about dangers we've faced, about things to avoid. Warnings born from experience, from learning, from growth. We might warn about environmental destruction, about the dangers of certain technologies, about the importance of cooperation, about the value of peace. But here's something important to consider. Who decides? Who speaks for Earth? Who decides what to say? This would require international cooperation. It would require countries to work together, to agree, to represent humanity as one species, one planet, one civilization. This might be challenging. Countries have different values, different perspectives, different ideas about what to share. But this might also be the moment that brings humanity together. The moment we realize we need to work together. The moment we see ourselves as one species, one planet, one voice. Scientists would likely play a central role. They would help craft the message, they would ensure it's scientifically accurate, they would help encode it, they would help send it. But they would work with governments, with international organizations, with representatives from around the world. The message itself would be carefully crafted. It would be reviewed, revised, considered from many perspectives. It would represent humanity's best qualities. Our curiosity, our wonder, our desire to connect, our hope for peace, our desire to learn. Once sent, the message would travel at light speed across the vastness of space. It would take years to arrive, decades, centuries. By the time it arrives, humanity might have changed. We might have evolved, we might have learned new things, we might have grown. But the message would still represent who we were when we sent it, what we knew, what we hoped, what we wanted to share. Then we would wait, patiently, for a response. A response that might take years to arrive, decades, centuries. A response that might never come. But we would wait. With patience, with hope, with wonder. If a response does arrive, the process would begin again. We would decode it, we would understand it, we would learn from it, we would respond again, slowly, patiently, building a conversation that spans generations, that spans centuries, that spans the rise and fall of civilizations. This conversation would be unlike any other. It would be slow, deliberate, patient. Each exchange would take years. Each response would require careful thought. Each message would represent humanity at that moment. Who we are, what we know, what we hope. But it would also be beautiful. It would be a connection across vast distances. A sharing of knowledge. A building of understanding. A relationship that spans time and space. The exchange of knowledge would be particularly fascinating. They might share scientific discoveries we haven't made yet. They might share technologies we can't imagine. They might share understanding of the universe that's beyond our current knowledge. Imagine learning about physics we haven't discovered, about chemistry we don't understand, about biology that's completely different from ours, about the nature of space and time, about the structure of the universe, about things we can't even imagine. They might share solutions to problems we're facing: climate change, energy production, resource management. They might have solved these problems long ago. They might share their solutions, their methods, their understanding. They might share warnings about dangers we haven't encountered yet, about mistakes they've made, about things to avoid. This would be valuable. It would help us avoid pitfalls. It would help us grow more safely. We might share our discoveries with them, our understanding, our art, our culture, our way of seeing the universe. We might share our music, our literature, our philosophy, our values, our way of being human. They might find our perspective interesting, our way of thinking, our way of experiencing the universe. Even if they're more advanced, we might have unique insights, unique ways of understanding, unique perspectives that they haven't considered. This exchange could accelerate human progress. We might learn things that would take us centuries to discover on our own. We might avoid mistakes they've already made. We might benefit from their experience, their knowledge, their wisdom. But this acceleration would be peaceful. It wouldn't be forced. It would be shared, offered, accepted gradually. We would still need to understand, to process, to adapt. The knowledge would come slowly, over years, over decades, over centuries. But it would be transformative. Human civilization might advance faster, but it would still advance naturally. We would still need to learn, to understand, to grow. The knowledge would help, but we would still need to do the work, to make the discoveries our own, to integrate them into our understanding. But there would also be challenges, misunderstandings, cultural differences, different ways of thinking, different values, different perspectives. These differences might be magnified by distance, by time delays, by the difficulty of communication. Imagine trying to explain human emotions to a species that doesn't experience them the same way. Or trying to understand their concepts when we don't have equivalent words. Or trying to share our art when they might not perceive beauty the same way. These challenges would be significant, but they would also be fascinating. They would push us to think differently, to understand differently, to grow. Language barriers would be immense. Even if we could decode their message, understanding meaning would be challenging. Words carry cultural context, they carry history, they carry assumptions. Translating between human languages is difficult. Translating between species would be far more challenging. But mathematics might help, science might help. Images might help, music might help. These might be more universal. They might bridge gaps that words cannot. They might convey meaning across vast differences. The time delays would add complexity. By the time we receive a message and respond, years would have passed. By the time they receive our response, more years would have passed. Conversations would span decades, centuries. This would require patience. It would require long-term thinking. It would require commitment across generations. But these challenges would be part of the process. Part of learning, part of growing, part of building understanding across vast differences. They would be peaceful challenges. They would require patience, they would require care. But they would also be beautiful. They would show our ability to adapt, to understand, to connect despite differences. There's another possibility. We might contact multiple civilizations. We might receive signals from several different star systems. We might be part of a network, a cosmic community, a web of civilizations, sharing knowledge, sharing understanding, sharing connection. This network effect could be profound. Knowledge could spread, understanding could grow, civilizations could learn from each other. They could build on each other's discoveries. They could create something larger than any single civilization. A cosmic community. A network of intelligence. A web of connection across the galaxy. This vision is peaceful, it's calming, it's full of wonder. It shows the universe as a place of connection, of sharing, of learning, of growth. As we continue our journey, we'll explore the long-term implications, how contact might change humanity's future, how it might shape our evolution, how it might affect our place in the cosmos. But always remember, communication itself would be peaceful, patient, full of wonder. It would require care. It would require thought. It would require time. But it would be beautiful. It would be a connection across the vastness of space. A sharing of knowledge. A building of understanding. The journey from first contact to ongoing communication is long. It requires patience. It requires care. It requires humanity to work together. But it's a journey worth taking, a connection worth building, a conversation worth having. So as we drift deeper into this exploration, keep in mind that communication would be slow, deliberate, patient, but also beautiful, full of wonder, full of possibility, a connection across time and space, a sharing of knowledge, a building of understanding. To understand first contact fully, we need to explore the long view. How contact might change humanity's future. How it might shape our evolution. How it might affect our place in the cosmos. Chapter 7. The Long View. Humanity's Future Among the Stars. First contact would be a moment, a single point in time, but its effects would ripple outward. Across years. Across decades. Across centuries. Across millennia. How would contact change humanity's future? How would it shape our evolution? How would it affect our place in the cosmos? Let's think about the long view, not just what happens in the first year, or the first decade, but what happens over centuries, over thousands of years, over the long arc of human history. One immediate effect would be motivation. Contact would prove that we're not alone. that intelligence exists elsewhere, that the universe is full of life. This would inspire space exploration. It would show that there's something out there, something worth reaching, something worth connecting with. Space programs might receive more funding, more support, more interest. People would see the value in exploring, in reaching out, in being part of the cosmic community. Missions to other star systems might become priorities, not just for science, but for connection, for communication, for being part of something larger. But here's something important. Physical travel to other star systems is incredibly difficult. Even at light speed, it takes years to reach the nearest stars. And we can't travel at light speed. Our fastest spacecraft travel at a tiny fraction of light speed. It would take tens of thousands of years to reach even the nearest stars. So communication might be easier than travel. We might communicate with civilizations we'll never visit. We might exchange knowledge with beings we'll never meet. We might build relationships across distances that physical travel can't bridge. But contact might still inspire us to try, to develop new technologies, to find new ways to travel, to push the boundaries of what's possible. This inspiration would be peaceful. It would be hopeful. It would drive us forward. Contact might also change how we see ourselves. We would no longer be alone. We would be part of a cosmic community, part of a network of civilizations, part of something larger than ourselves. This perspective shift would be profound. It would affect how we think, how we act, how we see our place in the universe. We might become more cooperative, more unified, more aware of our shared humanity. We might see Earth as one planet, one species, one civilization. This unity would be beautiful. It would show our best qualities, our ability to work together, our ability to see beyond our differences. We might also become more responsible, more aware of our impact, more careful about our planet, more thoughtful about our future. If we're part of a cosmic community, we have a responsibility to preserve Earth, to be good neighbors, to represent humanity well. Contact might accelerate our learning. If they share knowledge with us, we might learn things that would take centuries to discover on our own. We might avoid mistakes they've already made. We might benefit from their experience, their wisdom, their understanding. This accelerated learning could transform human civilization. We might develop new technologies, new understanding, new ways of thinking. We might advance faster than we would on our own. This advancement would be peaceful. It would be gradual. But it would be profound. Over centuries, human culture would evolve. Our art, our music, our literature, our way of seeing the world, all would be influenced by contact, by the knowledge that we're not alone, by the connection to other civilizations, by the understanding that we're part of something larger. Our science would advance. We would learn new things about the universe, new physics, new chemistry, new biology, new understanding of how the cosmos works. This knowledge would be shared. It would benefit all of humanity. It would advance our civilization. Over millennia, humanity might spread. We might colonize other planets, other star systems. We might become a spacefaring civilization. Not just exploring, but living, thriving, across multiple worlds. This expansion would be gradual. It would take thousands of years. But contact might inspire it. It might show us that it's possible, that other civilizations have done it, that we can too. The first steps would be within our solar system. Mars might become a second home. We might establish colonies there, permanent settlements. People might live there, work there, raise families there. Mars would become a second world for humanity, a second chance, a second home. The Moon might become a way station. a place to refuel, a place to prepare, a place to launch missions deeper into space. Lunar bases might be built, they might support Mars missions, they might support asteroid mining, they might be stepping stones to the stars. Asteroids might be mined for resources, they contain metals, water, materials we need. Mining them would be challenging. But it would be possible, it would provide resources for space exploration, it would make deeper missions feasible. Space stations might become permanent settlements. Not just research stations, but actual communities. People might live there permanently, they might work there, they might build lives there. These stations might grow. They might become cities, floating cities in space. These would be challenging, but they would be possible. They would be steps toward something larger. Steps toward becoming a spacefaring civilization. Steps toward spreading across the galaxy. Steps toward being part of the cosmic community. Each step would take time. Decades. Centuries. But contact might inspire us. It might give us motivation. It might show us that it's possible, that other civilizations have done it, that we can too. Eventually we might reach other star systems, not through fast travel, but through patience, through generationships, through the slow expansion of humanity across the galaxy. Each new world would be a new home, each new system would be a new frontier, but all would be connected. Through communication, through shared knowledge, through the cosmic community. Humanity might evolve, not just culturally, but biologically. Different environments might select for different traits. Humans on Mars might adapt to lower gravity. Their bones might become denser. Their muscles might develop differently. Their cardiovascular systems might adapt. Over generations, Martians might become different from Earthlings, but they would still be human, still connected, still part of the same species. Humans on other worlds might adapt to different atmospheres, different pressures, different compositions. They might develop different lung capacities, different blood chemistries, different ways of processing oxygen, or they might need technology to survive. They might always depend on life support systems. They might always need protection from their environment. Humans in space stations might adapt to microgravity. They might become taller, their spines might lengthen, their bodies might change. They might become adapted to life in space, but they would still be human, still connected, still part of humanity. Over thousands of years, humanity might diversify. Different populations on different worlds, different adaptations, different traits. But we would still be human, still connected, still part of the same species, still part of the cosmic community. Technology might also help. Genetic engineering might allow us to adapt faster, to survive in different environments, to thrive in space. But this would be gradual, careful, thoughtful. It would require consideration, it would require wisdom, it would require care.
Evolution would be peaceful.
It would be natural, it would be gradual. It would happen over generations, over centuries, over millennia. But it would happen. Humanity would diversify, but we would remain connected. By communication, by shared history, by shared humanity. Our technology would advance. We might develop new ways to travel, new ways to communicate, new ways to live. We might learn from other civilizations. We might build on their knowledge. We might create technologies we can't even imagine today. This advancement would be peaceful, it would be gradual, but it would be profound. We might learn about new forms of energy, ways to harness power we haven't discovered, ways to travel faster, ways to communicate more efficiently, ways to live in space, ways to adapt to different environments. We might learn about new materials, substances with properties we can't imagine, materials that could revolutionize construction, that could enable new technologies, that could change how we build, how we live, how we explore. We might learn about new forms of computing, ways to process information we haven't thought of, ways to store data, ways to think, ways to understand. This could accelerate our learning. It could help us solve problems. It could help us grow. We might learn about biology, about life, about how it works, about how it evolves. This could help us understand ourselves better. It could help us adapt. It could help us thrive. All of this learning would be peaceful. It would be shared. It would be gradual. We would need to understand, to process, to adapt. But it would be transformative. It would change humanity. It would advance our civilization. It would connect us to something larger. But there's another possibility. We might be the first. We might be the ones making contact. We might be the ones reaching out. If so, we have a responsibility to be careful, to be thoughtful, to represent humanity well, to be good neighbors in the cosmic community. We might also learn from older civilizations. If they've been around longer than us, they might have wisdom to share. They might have learnt things we haven't. They might have solved problems we're still facing. This learning would be valuable. It would help us grow. It would help us advance. The long-term perspective is peaceful. It's calming. It reminds us that change happens slowly, that civilizations evolve over millennia, that we're part of a long story, a cosmic story, a story that spans billions of years. Civilizations might rise and fall, but the network of communication might persist. Knowledge might be preserved. Understanding might be shared. The cosmic community might continue, even as individual civilizations change, even as they evolve, even as they transform. This vision is beautiful. It shows the universe as a place of connection, of sharing, of learning, of growth. It shows civilizations not as isolated, but as connected, as part of a larger network, as part of a cosmic community. Imagine a galaxy where civilizations share knowledge, where discoveries spread, where understanding grows, where each civilization builds on what others have learned, where progress accelerates, where the universe becomes a place of learning, of growth, of connection. This network would be peaceful. It wouldn't be forced. It would be voluntary. Civilizations would choose to participate. They would choose to share. They would choose to learn. The network would grow organically. As more civilizations join, as more connections are made, as more knowledge is shared, the network would be resilient. If one civilization falls, others would continue. Knowledge would be preserved. Understanding would persist. The cosmic community would endure, even as individual civilizations rise and fall, even as they evolve, even as they change. The network would also be diverse. Different civilizations, different perspectives, different knowledge, different understanding. This diversity would be valuable. It would enrich the network. It would help everyone learn. It would help everyone grow. New civilizations would join. They would bring new perspectives, new knowledge, new understanding. They would learn from older members. They would contribute their own discoveries. The network would grow. It would evolve. It would become richer, more diverse, more valuable. The network would be peaceful. There would be no coercion, no force. Just voluntary participation, just shared interest, just mutual benefit. Civilizations would join because they want to. They would share because they want to. They would learn because they want to. This vision gives us hope. It shows that we're not alone, that we're part of something larger, that we can learn, that we can grow, that we can connect. It's a peaceful vision, a hopeful vision, a beautiful vision. It's also a patient vision. It would take time to build, centuries, millennia. But it would be worth it. The connection would be worth it. The learning would be worth it. The growth would be worth it. The wonder would be worth it. The preservation of Earth would become even more important. If we're part of a cosmic community, we have a responsibility to our planet, to preserve it, to care for it, to ensure it remains habitable, for us, for future generations, for the cosmic community we're part of. Contact might give us perspective. It might remind us that Earth is precious, that it's rare, that it's worth protecting. It might inspire us to take better care of our planet, to address climate change, to preserve biodiversity, to ensure Earth remains habitable. We might learn from other civilizations. They might have faced similar challenges. They might have solutions. They might have warnings. They might share their experiences, their methods, their understanding. This could help us. It could accelerate our progress. It could help us avoid mistakes. But we would still need to do the work. We would still need to change. We would still need to adapt. The knowledge would help. But we would still need to act, to care, to preserve. This responsibility would be peaceful. It would be thoughtful. It would require long-term thinking. It would require us to see beyond our immediate needs, to think about the future, about generations to come, about our place in the cosmic community. It would also be beautiful. It would show our maturity, our wisdom, our ability to think long-term, our ability to care, our ability to preserve. It would show that we're ready to be part of something larger, ready to take responsibility, ready to grow. The evolution of human culture over millennia would be fascinating. How would contact shape us? How would it change our values, our goals, our understanding of ourselves? These changes would be gradual. They would happen over centuries, but they would be profound. We might develop a cosmic perspective, a sense of ourselves as part of something larger, a sense of responsibility to the cosmic community, a sense of wonder at being part of this vast network of life and intelligence. This perspective would be peaceful, it would be calming, it would remind us of our place in the cosmos, small, but connected, part of something vast, part of something beautiful. As we conclude our journey, we'll bring together all these threads: the search, the signal, the distance, the life, the response, the communication, the long view, all connected, all part of the same story. The story of first contact, the story of connection, the story of wonder. But always remember, the long view is peaceful, it's patient, it's full of wonder. It reminds us that we're part of something larger, that we're connected, that we're not alone. The journey from first contact to long-term relationship is long. It spans generations. It spans centuries. It requires patience. It requires care. It requires humanity to work together. But it's a journey worth taking, a connection worth building, a future worth creating. So as we drift toward the end of this exploration, keep in mind that first contact would be just the beginning, the start of a long journey, a journey of connection, of learning, of growth, a journey that spans time and space, a journey full of wonder, full of possibility, full of peace. Conclusion: we've traveled a long way tonight. From radio telescopes, listening to the stars, to the moment a signal might arrive, to the vast distances that separate us, to imagining what alien life might be like, to how humanity might respond, to how communication might begin, to the long view of humanity's future. We've explored the science, the SETI searches, the Drake equation, the Fermi paradox, the challenges of interstellar communication, the possibilities of alien life, the implications for humanity. We've learned about radio telescopes, how they work, how they search, how they listen. We've learned about signals, how they travel, how they're detected, how they might be decoded. We've explored the vast distances of space, the time delays of light speed, the patience required for cosmic conversations. We've imagined what alien life might be like, how civilizations might evolve, what technology advanced beings might have. We've considered how humanity might respond, how the world might change, how we might adapt, how we might grow. We've explored the long-term implications, how contact might shape our future, how it might inspire us, how it might connect us to something larger. But through it all, one theme has remained constant: wonder, curiosity, the peaceful search for connection, the patient hope that we're not alone. The search itself is valuable, whether we find anything or not. It shows our curiosity, our wonder, our desire to explore, our hope for connection. It shows that we're looking outward, that we're reaching out, that we're open to possibility. The listening is peaceful. It requires patience. It requires commitment. It requires hope. But it's also calming. It's meditative. It connects us to the vastness of space, to the wonder of the cosmos, to the possibility of connection. The search itself is beautiful. The listening is peaceful. The possibility is enough. Whether we ever find anything or not, the search has value. It shows our curiosity, our wonder, our desire to connect, our hope that somewhere, in the vast cosmos, other civilizations are also searching, also listening, also wondering if they're alone. If we do make contact, it would change everything. But it would also be peaceful, careful, thoughtful. It would require patience. It would require cooperation. It would require humanity to work together. But it would be beautiful. It would show our best qualities, our curiosity, our ability to adapt, our desire to connect. The vastness of space is not frightening. It's peaceful. It's calming. It reminds us of our place in the cosmos, small, but connected, part of something vast, part of something beautiful. The time delays are not frustrating. They're peaceful. They remind us that some things take time, that patience is valuable, that the journey itself is important, not just the destination. The unknown is not scary. It's full of wonder, full of possibility, full of the beauty of not knowing, of searching, of hoping. So as we drift towards sleep, let these thoughts settle: the peaceful search, the patient listening, the wonder of possibility, the beauty of not being alone, the calm acceptance of what we don't know, the peaceful hope that somewhere, civilizations are searching, are listening, are wondering. The search continues, patiently, peacefully, with wonder and hope. And that's enough. The search itself is beautiful. The listening is peaceful. The possibility is enough. Tonight, we've explored what might happen. We've imagined the possibilities. We've considered the challenges. We've dreamed of connection. We've hoped for contact. We've wondered about the future. But whether contact happens or not, the search has value. It shows our curiosity, our wonder, our desire to explore, our hope for connection. It shows that we're looking outward, that we're reaching out, that we're open to possibility. The vastness of space is not empty. It's full of possibility, full of wonder, full of the potential for connection. Even if we never find anyone, the search connects us to the cosmos. It reminds us of our place. It fills us with wonder. The patience required is not a burden, it's a gift. It teaches us to wait, to hope, to wonder. It teaches us that some things take time, that some journeys are long, that some searches are worth the wait. The unknown is not frightening, it's full of beauty, full of possibility, full of the wonder of not knowing, of searching, of hoping, of dreaming. So let these thoughts drift with you: the peaceful search, the patient listening, the wonder of possibility, the beauty of the cosmos, the calm acceptance of what we don't know, the peaceful hope that somewhere, civilizations are searching, are listening, are wondering, just like us. Sweet dreams, and keep looking up at the stars. The search continues, the listening continues, the wonder continues, one sleepy soul at a time. And remember, whether we're alone or not, we're part of something vast, something beautiful, something full of wonder, the cosmos itself, the universe. The endless possibility of connection, and that's enough, that's beautiful, that's peaceful. Good night, and may your dreams be filled with stars, with wonder, with the peaceful hope of connection, with the calm acceptance of the unknown, with the beauty of the search itself. As you drift toward sleep, remember this. The search continues. Every night, every day, somewhere, a telescope is listening. Somewhere, scientists are searching. Somewhere, hope persists. Somewhere, wonder continues. The cosmos is vast, it's full of stars, full of planets, full of possibility, full of wonder. Whether we're alone or not, we're part of this vastness. We're part of this beauty, we're part of this wonder. The search itself is enough, the listening is enough, the wonder is enough, the possibility is enough. Whether we find anything or not, the search has value. It shows our curiosity, our wonder, our desire to connect, our hope that we're not alone. So sleep peacefully. Dream of stars. Dream of possibility, dream of connection, dream of wonder. And know that somewhere, the search continues, the listening continues, the hope continues, the wonder continues. One sleepy soul at a time, one peaceful night at a time, one moment of wonder at a time. The search continues, the hope persists, the wonder endures. Sweet dreams, and keep looking up at the stars. The cosmos is waiting, the possibility is there, the wonder is eternal. Good night.